Hello everyone, welcome back to my class. This is the second part of 2020 past question solution series on physics. Uh, in our last question, we've solved from question 1 to 10. So we're going to continue from there, which is question 11. So question 11 says, the air in the stem of a mercury in, in glass thermometer should be expelled before introducing mercury so that A, enough mercury may enter the bulb. B, the glass of the bulb may not crack if the mercury expand to, to compress the air. The mercury may not evaporate. And D, the mercury rise in the tube may not be subjected to varying air pressure. The presence of air in the stem uh, may cause expansion and contraction, which will vary the pressure of the air. So the correct option here is option D. Therefore, it need to be expelled before introducing mercury. So that is question 11. So question 12 says, a steel wire of 2.0 millimeter mercury cross-sectional area or cross-section is held straight but under no tension by attaching it firmly to 2 points, right? To 2 points at a distance of 1.5 meter apart at 30 degrees Celsius. If the temperature decreases to negative 10 degrees Celsius and the 2 points remain fixed, what will be the tension in the wire? So if you look at this question critically, you will observe that there's a change in temperature. Initially, the temperature is 30 degree and it dropped to negative. So when this happens, there is going to be a kind of shrinking. It compress. The steel wire compress because of change in temperature. That is, the temperature, the material has been cooled to a negative 10 degrees Celsius. So it's going to also pass through a kind of strain, right? So from here, we are given that solution. We are given that the linear expansivity. Let's start from uh, the area, the cross-sectional area of the of the wire. Let's assume here is the wire of cross-sectional area. So the cross-sectional area A is said to be 2.0 mm of mercury, right? Or if you look at all our this thing, they are in a meter. Here is meter. Here is also in a meter. So we have to convert this thing to meter. So in order for us to do that, in meter, area will be equal to 2 times 10 raised to power minus 6 meter cube. Remember that 1 meter is equal to 100 centimeter. So in meter cube, if you square this, so that will give us the conversion rate. That is uh, 1 meter squared will be equivalent to what? To 10 raised to power 4. So this is supposed to be minus 4. Sorry, minus 4. Are we together? Meter squared. So we have converted that to meter squared. That is our area. And it is fixed, right, at a particular point. And the distance between the 2 points is said to be 1.5 meter, which serves as our length, 1.5 meter. So that is the length of the steel wire. Exactly. So, and the initial temperature, theta 1, is said to be 30 degrees Celsius. And the final temperature, theta 2, after cooling, is a negative 10 degrees Celsius. So let's calculate our change in temperature here, which is going to be here, theta 1 minus theta 2. That will be 30 minus, into bracket, minus 10. That will give us change in theta to be equal to 30 minus 10. That will give us a 40 degrees Celsius. So we have gotten our change in temperature, voltage, and we have gotten our length, right? So here is our length. Our length is equal to 1.5 what? 1.5 meter. So then our linear expansivity alpha is said to be 1.1 times 10 raised to power minus 5 per degree Celsius. And we are given that the Young modulus is given to be 2 times 10 raised to power 11 Newton per meter squared. So now we are looking for the tension, which is equivalent to the force, right, on the wire. So tension T is equivalent to the force on the wire that we don't know. So how do we come about the correct solution to this? You should remember, since we are having linear expansivity, we are having length, we are having area and all that, we now recall that linear expansivity alpha is equal to change in length, which is the extension, all over original length times what? Change in theta. Is that understood? So in order for us to get the force we are looking for, there is no force in this formula. But we know that since we are giving Young modulus, there's a relationship between Young modulus and the force. We know that Young modulus is equal to stress all over strain. I hope this is taken. So stress over strain. From stress, we can get our force all over area. So in this case, it shows that we need to find stress, right? So that we'll be able to use it to get our area, since our force, since we know our area, right? Good. But how do you get stress? We need strain and stress. We need strain. We are already having we've gotten what is it? A Young modulus. Then we need to find our strain. From our strain, we get our what? Our stress. What is strain? How do we get strain? Strain is equal to change in length all over original length. So how do we get strain? We don't have change in length, but we have original length. Is that clear? So from this relationship, we can get our strain, right? So how do we do that? We have that alpha is equal to change in length all over original length times what? Change in theta. Is that clear? We can make this, right? From here, we can make it subject to the formula. Can make it subject to the formula. Is that clear? So let's take it down to this point. From here, alpha equal to change in length all over original length times what? Change in theta. So the whole of this is strain, right? The whole of this is strain. So this means that alpha is equal to strain all over change in what? Change in theta. So which implies that our strain will be equal to alpha multiplied by change in theta. So therefore, strain will be equal to, what is alpha? Alpha is given to be 1.1 times 10 raised to power minus 5. And change in theta, we have already calculated it to be 40. So we have 40. When you multiply, your strain should give us, multiply, that will give us 4.4 times 10 raised to power minus 4. Strain has no unit. So this is our strain. So since we have gotten our strain, we can now bring back this formula that the Young modulus is equal to stress all over strain. Is that correct? Stress over strain. Therefore, our stress is equal to Young modulus multiplied by strain. Are we together? So what is our Young modulus? Young modulus is given to be 2 times 10 raised to power 11 multiplied by our strain, which is 4.4 times 10 raised to power minus 4. When you do that, you are going to have our stress to be 8.8 times 10 raised to power 7 times 10 raised to power 7 Newton per meter squared. So since we have gotten our strain, we can now get our force. Remember, we have gotten our stress. Remember, stress is equal to force all over area. Exactly. Therefore, force is equal to stress multiplied by what? Multiplied by area. So what is our stress? Our stress is 8.8 times 10 raised to power 7. Exactly. Then multiply by what? Area, which is 2 times 10 raised to power minus 4. So when you multiply this together, you end up having 176 Newton to kilonewton. That will give us 0.176 kilonewton. I hope this is taken. So this is how to approach this question. That gives us option D as the correct answer. So the correct answer here is option D, right? So that's about question 12. We move to question 13. Question 13 says, a uniform narrow bore tube closed at one end contains some dry air which is sealed by a thread of mercury 15 centimeter long. When the tube is held vertically with the closed end at the bottom, the air column is 2.0 centimeter long. But when it is held horizontally, the air column is 24 centimeter long. Calculate the atmospheric pressure. All that this is under the atmospheric pressure. So we have initially, let's say, here is the tube. Remember, the tube is uniform, the uniform cross section, right? Meaning that the area is the same all through. So, and it said that it contains dry air that is sealed by a thread of mercury happening to 15 centimeter. So let's assume the thread of mercury is like this, right? So, and we have air trapped inside this. So this is the thread of mercury. And say the length of this is said to be 15 centimeter. Take note. So this is when vertical, right? When held vertical with the closed end at the bottom, like what we have here. So the air column is 20 centimeter. So the air column, meaning that these are the air column, the down one is said to be 20 centimeter when held vertical. So the air column is 20 centimeter and that of mercury is 15 centimeter. So the air column is 20 centimeter. Now the next thing is that when it is held horizontally, the air column is 24 centimeter. So when it is now held horizontally, something like this, we still maintain the thread of the mercury to be 15 centimeter, only that this case, something changed, that is the air column. So this still remains as a 15 centimeter. 15 centimeter. So the air column here now become 24 centimeter. 24 centimeter. This is under Bohr's law. So the pressure, right? The pressure on this particular orientation, we call it P1. The pressure is due to the coulomb of the mercury and the atmospheric pressure, right? Atmospheric pressure. So the pressure now, P1 here, under this condition, P1 is equal to pressure due to atmospheric plus the pressure due to the coulomb of the mercury. Is that clear? So that is the pressure here. The volume here, V1, will be equal to 20 centimeter. You know why? Because here, volume is proportional to what? To the length, right? You know, volume is equal to area times what? The height or the length. But they say the tube is a uniform cross section, so we tend to use A to be equal to 1. Therefore, volume is proportional to the height or the length of the air column. So V1 here is going to be 20 centimeter. So under this condition, The only pressure here is due to what? The atmospheric. So the pressure due to atmospheric. Here, it is not vertical, so it does not exert pressure. So the pressure here, the mercury here is not vertical, therefore it does not exert pressure. And the pressure only due to what? Atmospheric. In that case, our P2 here is equal to what? P atmospheric. Is that clear? And our V2 here will be equal to 24 centimeters. Is that understood? So we apply Boss law here, that is P1 V1 equal to what? P2 V2. So anywhere we see P1, we write P atmospheric, right? Plus what? P due to the mercury thread equal to P atmospheric also multiplied by what? Here multiplied by the volume V1, which is what? Which is 20. So let's call it V1 here multiplied by V2. So putting the value here now, we have P atmospheric plus what? 15 all into bracket what? V1 is 20 equal to P atmospheric, right? Multiplied by 24. Is that clear? So when that one is done, you open bracket, you're going to have 20 multiplied by this, that will give us 20 P atmospheric, right? Plus 20 multiplied by 15, that will give us 300, which will be equal to 24 P atmospheric. So the next thing is to collect the lifetimes. I'm going to have 24 P atmospheric, that is what we are looking for, minus 20 P atmospheric equal to 300, right? So therefore, we have 4 P atmospheric equal to what? 300. This implies that P atmospheric is equal to 300 divided by 4. That will give us 75 centimeter of mercury. I hope this is taken. So that is about question 13. And our correct option here is option C. So moving to question 14. Question 14 says, a metal block of mass 2.5 kg was heated from 20 degrees to 80 degrees Celsius in 30 minutes using a 120 watt heater. Calculate the specific heat capacity of the metal using assuming there is no heat loss. So this is under electrical method of determining the specific capacity of solid. So solution here we are giving that quickly mass is equal to 2.5 kg and theta 1 is equal to 20 degrees Celsius. Can convert it to what? Convert it to Kelvin. That is 20 plus 273. That will give you 293. So we have 293 Kelvin, and theta 2 will be equal to what? 80 degrees Celsius. Convert it to Kelvin. That is that will give us 353. So we have 353 Kelvin. Quickly, we are going to find change in temperature. Quickly find it. That is 353 minus 293. That will give us 60 Kelvin. So we have gotten your 60 Kelvin as change in temperature. Then again, you are giving power to be equal to 120 watt, and the time T is given to be 30 minutes. Quickly convert this to a second. That is multiplied by 60. That will give us 1,800 seconds. 1,800 seconds. Now you recall that under this, the heat gain by the metal is MC, change in theta, equal to the heat loss by the heating element, which is power multiplied by time. I hope this is understood. From here, quickly make your C subject of the formula. C that you're looking for is PT all divided by what? Mass times change in theta. So when this is established, the next thing for you to do is to plug in the value. What is our power? 120 multiplied by time, which is 1,800, all divided by mass, which is 2.5, multiplied by change in temperature, which is 60. So C now will be equal to, C will be equal to 216, 216,000 all divided by uh, 150, all divided by 150. So when you divide the numerator and the denominator, that will give us 1,440 joule per kilogram per Kelvin. Is that understood? As simple as ABC. So that's about question 14. Quickly, we move to the next question, which is question 15. So question 15 says, which of the following occurs when a substance solidifies? When a substance solidifies, it gives off its latent heat of fusion. Is that clear? Take note of this. When a substance solidifies, it gives us its latent heat of fusion, changing from liquid to solid. So that is option C. The next question is question 16. When water is boiling, what happens? It A, get hotter, B, increases in mass, C, decreases in mass, D, changes to steam. I believe you know this answer. That is option D, it changes to steam. Is that clear? So the next one is 17. Which of the following phenomena cannot be explained by molecular theory of matter? Right? Expansion, conduction, convection, and radiation. The answer is radiation. All these expansion, conduction, and convection, they involve the movement of molecules, right? Only radiation, which is an electromagnetic in nature, does not involve the movement of molecules. Therefore, it is the only phenomena that cannot be explained by molecular theory of matter. Is that clear? Okay. So moving on to the next question, which is question 19. So question 19 says, a string of length 1.0 meter vibrates in 10 loops. If the total mass of the string is this, and the tension in it is 10 Newton, calculate the frequency of the vibration. This is under the variation of the frequency of a string and its length, right? And the length of the string, variation of frequency with the length of a string. So it has this relationship that F is equal to 1 over 2L root of the tension all over the mass. Is that clear? And here we are given that the length is this, the 10 loops, that is to say, we're going to calculate the frequency for a loop, right? For a loop, calculate the frequency. Whatever you have, you multiply it by 10 to give you the total frequency for the 10 loops. So from here, quickly plug in the value 1 all over 2 multiplied by length, which is 1, then times root of the tension is 10 all over the mass is 1 times 10 raised to power minus 3. So this will give us 1 all over 2 times 1, that is 2. Then root of 10 divided by 10 raised to power minus 3 gives us 10,000, right? 10,000. So we find the square root of 10,000, that is 1 over 2 multiplied by 100, which will give us a 50 hertz for a single loop. So for 10 loop now, frequency for 10 loop will now be equal to 10 multiplied by what? 50, which is equal to 500 hertz. Exactly. So that gives us option. That gives us option D. I hope that is understood. So the next question is question what? So the next question is question 20. So question 20 says, a ray of light falls on a plane mirror so that the reflected ray makes an angle of 20 degrees with the incident ray. So let's assume we have here to be our plane surface, right? Here is our plane surface. Let's take this one to be the reflecting surface, the silvered surface. So we have the angle of incident like this, the reflected ray rather, we have it. We have the reflected ray, exactly, and the incident ray, that is incident ray rather, sorry, we have incident ray, here's a reflected ray, here's reflected ray, and we were told that the angle between the incident ray and the reflected ray is said to be what? 20 degree. So again, they said the mirror is turned about an axis to the right angles to the plane of the ray through an angle of 15 degrees. So this mirror is now turned through an angle of 15 degrees. Let's assume it's like this. It's now turned. Let me draw it first and bring it. So it's now turned in this manner. So this is the new direction of the what? Of the mirror. I have done a video explanation on a effect of mirror rotation. You can watch it. So when this happens, and this is at an angle theta to be what? 15 degree. Is that understood? So we are now asked to determine the new position of angles, what are now the possible angles between the incident ray and the new uh, reflected ray. So we keep the incident ray constant, then the new reflected ray, possibly like this. So we are now looking for the angle between this and the new reflected ray. That's what we are looking for. Is that understood? But there are certain key points you need to understand in tackling this type of question. Fact to understand. Fact one is that angle between uh, incident incident and reflected ray is equal to 2i. In that my video, you are going to understand why it is going to be why it is 2i. So the second fact is that if mirror rotates by certain angle theta, the reflected ray will rotate twice. That is, rotate by what? Twice of the angle. Is that understood? So this is the fact. So from what we are given, they said the angle between the incident ray, this is incident ray, this is reflected initial, is 20. So from the first fact, they say the angle between incident ray and reflected is what? 2i. Therefore, it shows that 2i is equal to what? 20 degree. Therefore, I will be equal to what? 10 degree. That one is there. Is that clear? Now, the next thing you're looking for now is the rotation, angle of rotation, right? Of the final position of the reflected ray. Is that clear? So from the second fact, if mirror rotate by what? By theta, the reflected ray rotate by what? 2 theta. So in that case, since our angle of rotation of the mirror is 15 degree, so reflected ray will rotate by what? 2 theta, which equal to what? 2 times what? 15. As simple as this. That is what? 30 degree. So the next thing is to add this 30 degree to the initial. So the whole of this. That's going to be what? 30 degrees. So the new position now is new possible angles between incident ray and a new reflected reflected ray will be equal to what? 20 plus what? 30, which will give us a 50 degree. Is that clear? So, which is option D. 10 degree, 50 degree. Is that clear? As simple as ABC. So that's about question 20. I think we are going to stop here in today's class and continue from here in our next class. Should you have any problem, any question you don't understand, please let me know in the comment section. From there, I will sort it out. Thank you for your time. See you in the next class.